Hello, it's Andy King, Chair of the Fire and Life Safety Section with the International Association of Fire Chiefs. Thanks for joining us again today as we continue our discussion on Introduction to Fire Alarm Systems. Today we'll be discussing initiating devices. With that, also joining us is Chief Michael O'Brien. Chief, would you like to review the agenda and learning objectives?
Thanks, Andy. Today we've got two great technical experts with us that are going to help us go through what an initiating device is. And these will include spot type detectors, line type detectors, air sampling, gas. We're also going to talk about manual pull stations, the connection of the fire sprinkler system or the water flow switch, and we'll have a chance to ask our experts some questions at the end. So Richard, I'm going to hand the slides off to you and let us get into our next segment here on initiating devices.
Okay, thank you, Chief, and welcome back, everyone. As I mentioned in a previous section, a fire alarm system is activated from initiating devices that send input signals to the fire alarm control unit. Now, initiating devices are classified either as manual or automatic input devices, and these devices or input devices that require no human intervention are classified as automatic initiating devices, and they respond to any number of physical changes associated with a fire, such as smoke, heat, or gas. A spot type smoke or heat detection device are two of the most common, and they require the energy of the fire to transport sufficient levels of smoke, heat, or gas to the location of the detector. Now, these devices essentially passively await the arrival of smoke, heat, or gas before they can begin sensing the threat of a fire. Now, these units are typically mounted on ceilings, but they can be mounted on walls as well. Now, looking at smoke detectors, they detect visible or invisible particles of combustion, in other words, smoke from a fire, and they are distinguished by the technology used to detect smoke from a fire. Now, the traditional technology used in smoke detectors since the 1970s has been ionization and photoelectric technology. Now, let me just spend a couple minutes here and explain the basics of how they operate. Now, the smoke chamber of an ionization device has a small amount of radioactive material called americium. Now, I should point out that this very, very small amount of americium really poses no threat to life or property. Now, this radioactive material ionizes the air, rendering the air inside the chamber conductive. Because the air is conductive, it permits current flow between two metal plates that's located in the chamber. When smoke enters the chamber, the ions stick to the smoke particles and there is a reduction in current flow. Now, this reduction in current flow can be equated to a given amount of smoke. So the detector goes into alarm when the current falls below a predetermined level. Now, looking at a photoelectric smoke sensor, it consists of a smoke chamber as well. But inside this smoke chamber, there is an LED light source and a receiver. And this receiver is known as a photodiode. Now, typically, the LED will pulse every 5 to 15 seconds. The LED and the photodiode that's located inside the chamber are arranged so that the light rays from the LED are not directed at the photodiode during clean air conditions, or in other words, a non-fire condition. However, when smoke particles enter the chamber, some of the light rays are scattered off the particles of combustion and they are reflected on the photodiode. When the photodiode receives the light, it generates an electrical current, causing the detector to operate. Now, ionization sensors, they are typically better at detecting smaller particles of combustion, usually from flaming fires. However, photoelectric sensors, they are generally better at detecting fires that produce larger particles of combustion, typically from a smoldering type of a fire. Hey, let's look at heat detectors. Now, these respond to thermal energy, obviously heat, and they activate when the detecting element okay, reaches either a predetermined fixed temperature or when a specified rate of temperature rise occurs. Looking at fixed temperature detectors, they activate when its sensing element becomes heated to a predetermined level, typically 135 degrees Fahrenheit or 194 degrees Fahrenheit. Now, one drawback about fixed temp detectors is they typically or may activate when the temperature of the surrounding air has exceeded that predetermined temperature set point of the detector. And this is because of a high rate of temperature rise from a rapidly developing fire. Therefore, the time between when the surrounding temperature reaches that predetermined set point and when the detector activates is known as thermal lag. Now, looking at a rate of rise detector, it will activate when the temperature rises at a rate exceeding a predetermined amount. This is usually 15 degrees Fahrenheit per minute. Now, both smoke and heat detectors can contain more than one sensing element to respond to a fire. Examples could include a combination rate of rise and a fixed temperature heat detector, or a combination smoke and a heat detector. As I mentioned, the traditional technology used in smoke detectors since the 1970s has been ionization and photoelectric, and they have really performed very well during this time. We've seen significant reduction in fire fatalities since the mid 1970s. However, these devices have really reached their limit in terms of faster detection and rejecting nuisance, or the term people like to use now is unwanted alarms. Now, in recent years, manufacturers have developed a new type of smoke detection uh, technology or smoke detectors that use multi-criteria technology, and they are designed to accomplish two things. Number one, they detect both smoldering and flaming fires equally well, which means what? It will allow occupants more time to safely exit the dwelling unit or the building. And number two, it will improve resistance to common nuisance or unwanted alarms, but most importantly, it will not sacrifice detection performance. Now, a multi-criteria smoke detectors contains multiple sensors that separately respond to physical stimuli such as smoke, heat, fire, or gases from a fire. Now, the output signals from these various sensors are mathematically evaluated by a microprocessor, and that is to determine when an alarm signal is valid. The microprocessor also will utilize filters to eliminate common nuisance sources. Now, this detection process only takes a couple seconds to either confirm that it is a true fire or to conclude that it isn't a true fire, thereby eliminating an unwanted alarm. One example, and there are different types of examples, but one example of a multi-criteria detector is the following. Number one, it could use an infrared sensor that detects the flame from a fire. It could also contain a carbon monoxide sensor, and that is really for nuisance immunity. It could contain a photoelectric sensor, and that is better for detecting smoldering type of fires. And it could have a heat sensor, and that is better or really intended to detect a flaming fire. Now, there are several benefits of using this multi-criteria technology over the traditional technology that has been used since the 1970s. Number one, it enhances the detection performance by detecting both flaming and smoldering fires equally well. Number two, it improves resistance to unwanted alarms without sacrificing detection performance. And then lastly, it really accomplishes all this in a very cost-effective product solution. Another type of automatic initiating device is a line type, which detects a fire along a continuous path. Two examples are projected beam smoke detectors and heat sensitive cable. Now, looking at beam detectors. They are often used in large open spaces, such as atriums, convention halls, auditoriums, gymnasiums, and where a building or portion of a building has a very high ceiling. A beam detector uses a light source and a photosensitive sensor that are arranged across a projected space so that the light rays from the light source normally fall on the photosensitive sensor. Now, when the smoke particles enter that light path, the intensity of the light is reduced and it will cause the detector to initiate an alarm signal. Now, looking at thermal cable, there are two types of heat-sensitive thermal cable. One type consists of two current-carrying wires that are separated by a heat-sensitive insulation that softens at the rated temperature, thus allowing the wires to make an electrical contact and send an alarm signal to the fire alarm control unit. The second type of heat-sensitive cable uses a single wire that is centered in a metallic tube, and the intervening space is filled with a substance that becomes conductive at a predetermined temperature, thereby allowing or establishing an electrical current between the tube and the wire. Now, these type of detection, that being heat sensitive, is ideally suited for storage racks in large warehouses, in large cold storage rooms, in road tunnels, and in power cable tunnels. So now let's turn our attention to air sampling detection. First type is duct smoke detectors, and they detect smoke that is present in the air moving through HVAC ductwork. Now, this type of smoke detection device is designed to prevent the spread of smoke through an HVAC system. And this will help prevent panic of building occupants and damage from the distribution of smoke and gases, not only through the HVAC system, but throughout the building. Now, looking at aspirating type of detection, it consists of a pipe distribution network that runs from a central detector in a housing. Um, uh, okay, and then this type of detection is really active because there is a fan located in the detector housing that runs continuously, which draws in air from the protected area back to the detector through the sampling ports and the piping system. Now, at the detector, the air is analyzed for smoke, heat, and gas that's produced by the fire. Aspirating type detectors are used in a wide variety of applications where the designer is really looking for and needs increased sensitivity, and that's usually to meet the owner's fire protection goals. Now, this type of detection is often used in areas that house valuable equipment, such as telecommunication and data centers. Gas detection. Now, toxic, flammable, and combustible gas detection systems are required by many model codes and should be installed to the same level of reliability as the fire protection system. Now, several examples of where gas detection may be required are in the following applications. Number one, carbon monoxide detection is required in many buildings having a permanently installed fuel burning appliance or an attached garage. Several examples are hotels, apartment buildings, K through 12 schools, nursing homes, and hospitals. Secondly, carbon monoxide, nitrogen dioxide, or propane detection is required many times in warehouse loading docks that have gas, diesel, or propane powered forklifts, as well as in vehicle repair garages or in enclosed parking garages. Hydrogen detection is often required in battery charging rooms. And carbon dioxide detection is required in rooms without mechanical ventilation systems that have more than 100 pounds of carbon dioxide that is used in beverage dispensing equipment. Gas detectors kind of makes sense. They have to be carefully matched and calibrated to the specific type of gas to be detected. For example, looking at carbon monoxide, nitrogen dioxide, these gases are not flammable or combustible, but they are toxic. In fact, they can be deadly. Looking at propane and methane and hydrogen, they are flammable. Another way fire alarm systems can be activated is by pull stations. And of course, they require human intervention to operate. Now, in its simplest form, the user activates an alarm condition by pulling the handle down on the pull station, which completes a circuit and locks the handle in the activated position. And when that happens, it will send an alarm signal to the fire alarm control unit. Now, an important thing to remember is after the operation, pull stations must be restored to the ready position or the non-alarm position using a special tool or key, and that is needed to reset the fire alarm control unit. Now, basic pull stations, they require only a single action or hand motion to activate. These devices are referred to as single action pull stations. However, these devices can be subject to unwanted alarm activations caused by people acting with malice or trying to pull a prank, such as students intentionally activating these pull stations in K through 12 schools or in college or universities. Other pull stations are dual action, and they require the user to perform a task before actually being able to pull down the handle, such as lifting up or pushing in a panel on the pull station. Um, the required double action it tends to discourage accidental or deliberately malicious nuisance alarms. Another type of pull station is a break glass pull station. They've been around for decades, and the user must break a glass rod in order to activate the station. And an activated break glass station is easily identifiable because of the broken glass rod on the outside of the unit. Next slide. Automatic fire sprinkler systems. They are used to obviously extinguish a fire, but they also really help to prevent the spread of the fire throughout the building. One type of a sprinkler system is a wet type, and it consists of sprinkler heads located throughout the building that are connected to a metal piping system. And the piping system is filled with water at all times. Now, when the heat produced from the fire reaches a predetermined fixed temperature, it will melt an element in the sprinkler head that releases water from the piping system to extinguish the fire. Um, Another type is a dry type sprinkler system in which the pipes are filled with air, pressurized air or nitrogen rather than water. Now, these systems, pressure systems, are typically used where winter temperatures fall below freezing, and it's necessary to keep the pipes dry until the water is needed. The air holds back or holds a valve known as a dry pipe valve in the closed position. When the sprinkler head trips, it releases the air in the pipe and allows the water to enter the pipe and flow to the open sprinkler or sprinkler heads, which will extinguish the fire. Now, fire alarm systems, they typically and are actually required to monitor the operation of the sprinkler system with special initiating devices. So let's take a minute and review some of these initiating devices. Next, initiating devices that are used in wet type sprinkler systems are either pressure or vane type. Looking at vane type water flow detectors, um, they detect water flow when the sprinkler head activates, obviously causing the water to flow in the piping system, which moves a vane or a paddle that's located inside the pipe, and it's connected to the water flow switch, which is mounted on the outside of the pipe. Now, after an adjustable retard period, and this is to compensate for normal water surges, the water flow switch will send an alarm signal to the fire alarm system. Whereas pressure switches, they detect water flow from changes in the water pressure. Now, these devices serve largely the same purpose as water flow switches in wet type systems, and they will sound an alarm when the sprinkler head or the sprinkler heads have been opened. Okay, Chief, back to you.
Covered a bunch of things there, from spot type detectors to line type detectors and air sampling. And I really appreciate you starting to touch the gas detection, because I really start to see that the fire service is seeing a lot more gas detection, even in places that, just because we have bulk CO2, we're starting to see detectors maybe in a fast food restaurant. And so it's new stuff. It's new things that that our responding crews have to be aware of. One question, or a couple questions, and I'm sure Andy might have one as well, but you know, Richard, one of the things I think that fire departments see, and it varies based on community, but typically national codes are now saying that duct smoke detectors, for the most part, need to be in a supervisory signal. So it doesn't necessarily alert the fire department. When a duct smoke detector is activated, what usually happens in a system?
It will shut down the air handling system, and that is to prevent the spread of particles of combustion, smoke, and gas throughout the building. And the National Fire Alarm and Signaling Code requires that the signal be a supervisory signal, but you know, it also permits the signal to, or the activated duct detector to generate an alarm signal where permitted by the AHJ. An important thing to remember about duct detection, though, is that it's really not intended, or is not allowed to replace where the code requires spot type detection.
Okay. And then one of the questions that we got online from somebody was really as it relates to water flow alarms, and you talked briefly about it. If a fire engine company seems to be responding to a building that was recently built and they're going on a lot of water flow alarms, is there a setting that they could work with either the alarm contractor or the fire sprinkler contractor, so that maybe it's not going off as easily? Is there a way that they could set that if they were having problems of just, it seems like the water burps and they go out on a fire alarm?
Yeah, I touched on that. I didn't you know, really elaborate on it, but there's what they call a retard setting, and you can delay the activation of an alarm. I think it's up to 90 seconds, and that is to allow for normal surges or water movement. So, you know, if you're getting a lot of that in a particular jurisdiction, you may want to dial in, you know, the most allowable time delay as possible. But I think the maximum could go up to 90 seconds. But yes, there is a way to adjust that.
And Chief O'Brien, this is Andy. We've definitely tried to standardize that within our jurisdictions for somewhere between 40 and 50 seconds, just so that we eliminate those falses from pressure surges, as you say. And the good news is that water is going to the fire, even though it potentially delays our response by 40 to 50 seconds before the alarm can be processed. But we've had good results with that.
We want to thank everybody, and as usual, please, if you have questions for future webinars, load them down in the comments where you're watching this video, whether it's on YouTube or on our social media. Please follow through, and if you have any suggestions, please don't feel free to reach out in the direct messages, and we'll be happy to get back to you. Have a safe day, everybody.